All right, so lesson for today is 5.6, as I mentioned, independent events. At this point in our study, we haven't taken a look at 5.5 yet, which is dependent events and conditional probability. So I'm going to take a look at that one afterwards. I want to just kind of get this is easier. So I'm going to get this one out of the way first. Independent events. Now I do need to contrast independent and dependent for you. So in your notes, we could just do this. Independent, let's just kind of define this, independent events. And the reason why I want to jump to 5.6 here right up to 5.4 is because we've talked about mutually exclusive events, right? And mutually exclusive events are events that are completely separate. There's no overlap in them, right? And so independent events are very much like that. They're virtually the same. An event happening like event A is independent of event B if event B has no influence on it. Okay, it's independent. So if you think about that word, independent, right? If you're an independent person, you can do it on your own, right? You're not depending on anyone else. You're independent. Or if I ask you to do an independent work assignment, that means you're supposed to do it on your own without any, influence from anyone else. So the independent part of it means that it's kind of a standalone thing. So if we talk about independent events, these are two or more standalone events where one event does not depend upon the other. Okay, so let's maybe just jot that down, try and formalize this. Independent events, okay? Two or more events which, this might not be the greatest English, sorry, I'm just coming out of my head, but two or more events which their outcomes do not depend on each other, or do not depend upon each other. Okay, all you English majors in the room, you can help me fix this if you want. Two or more events in which their outcomes do not depend upon each other, maybe. Does that sound better? We'll add in. What else should I do to that, English majors? Other than rewriting the whole thing. Oh, you want to do whose outcomes and not which their outcomes? Okay. Well, you can do that in your notes. Okay, that's too much for me to fix. All right. You guys get it, though, right? Independent. So the contrast, of course, would be dependent, okay? And like I say, that's for another lesson, the dependent events. We're going to talk about that tomorrow. But dependent events, okay, one event occurring depends upon the outcome of another event. So like I say, I'm going to take this opportunity to contrast independent and dependent events, which are not hard to understand, but I think we'll focus on the independent today. So, okay, so some examples, independent events. I mentioned yesterday, the chance that Josh will go to 7-Eleven, okay, and the chance that Ben will go to, can't remember what I said yesterday, Tim Hortons, okay. Now, those are independent events if those two guys don't know, have no plans to coordinate anything. If they just wake up and Josh does not consult Ben at all about where he's going to go, the chance of Josh going to 7-Eleven in the morning to pick up a coffee or 5, 10-cent candies, whatever they are now, they may be $1 now. I'm not sure what they are now. Really, father of 4 kids, when those 5-cent candies went to 10 cents, I tell you that was a big blow to my budget. But anyways, it's very sad. I was mad. Anyways, so those would be independent events if those guys didn't coordinate anything. Now, let's just talk about another example where Josh really wants to go to the same place to meet Ben for coffee before school. Okay? So if Ben decides that he's going to go to Tim Hortons, that would influence where Josh is going to go. You see that? So Josh is saying, well, okay, I'm going to go to Tim Hortons then too. So that Josh going to Tim Hortons now depends upon where Ben chose to go. You see that? Okay, another example. Let's say you're getting dressed in the morning and you really you for some reason you really need to wear blue pants, okay? Like I'm talking like bright blue, okay? You might have like really bright blue pants on today. Bright blue. Blue jeans not really counting. No, I'm talking about like the in-your-face blue pants, okay? So let's say this is the day where you really need to wear blue pants. And you have to choose a shirt to go with those blue pants. And you may look at your closet and you may consider the fact that you've already chosen the blue pants when you choose your top, right? Am I right? For me, I'm a nerdy math teacher. I don't care too much about how the pants and the top, I don't care how they conflict here. I think I'm looking pretty good today, but really I didn't put much thought into it. Now you might be pretty conscious about how you look, right? So maybe you would never ever wear, pink with that bright blue. Maybe that's just very disagreeable to you and your fashion palette, okay? You don't like that, all right? And so you would say, I'm not going to wear the pink top. I'm going to consider the blue top to match, or the green, or the black, or whatever. What? Which one? Green? Blue. Well, a blue with blue? What about if it's like another shade of blue? That doesn't count? Okay, let me rewind the tape here, okay? I'll just rethink what I said here. Let's just say that you're not going to wear a blue top with blue pants. So you're going to consider pink and green or black or white. Okay. So those are dependent. You see how they depend upon each other? Your decision to choose your top depends upon the decision for the pants. Those are dependent. Now, again, I'm talking a lot about dependent already, but independent, very easy, okay? Me, I have no fashion sense. So I have blue pants. Oh, that's green. Let's just back this up. Here I am over here, okay? Here's my blue pants, okay? And I even have a blue belt. Look at that. And let's just say that I don't really care what kind of top I wear, and I'm going to pick a green top. It doesn't matter to me. This event right here and this event right here are completely independent. I do not care. All right? Now, if I showed up looking like this, would you snicker underneath your breath at me, or would this be okay? Blue and green. Yeah, these don't exist in my wardrobe, so don't worry about it. But anyways, so the probability, now, if we're talking about the probability of independent events happening, it's pretty easy, pretty straightforward. We are going to now multiply probabilities just like the fundamental counting principle. Okay? So what's the chance that I would wear a green top? Well, let's say I have 2 green tops, not sure why I would, out of 6 green tops that I have in existence in my wardrobe. And I have, 3 blue pairs of pants out of the 7 pairs of pants I have in my wardrobe to wear to school. Then I simply, the chance that this outfit will occur is the multiplication of those probabilities. That's it. All right? So it's the multiplication. So 2 events happening together, right? So if we're talking about an outfit, there's 2 choices, one here and one here. The probability that those 2 events would occur in one sort of outfit here, you take the probability of each and you multiply. So what did we do the other day with mutually exclusive events? It was similar, right? But we added them because these are 2 events that are basically separate, right? So let's be careful with that. If we're talking about the outcomes of A and B, okay, or sorry, A or B, right here, or, we would add. If we're talking about A and B, which is what this is, the probability of A and B, that's the big difference, and they are independent, then you just take the probabilities and you multiply them, okay? So, that's independent events, okay? Again, I just want to make a real quick comparison here again to yesterday. So remember, this is in mutually exclusive events, we're talking about OR here. See that? That's A or B, we add. So OR is add, and is multiply. Okay? And let's just take a moment to just jot that little note down because that might be really helpful for you. So OR events, okay, is add. And events, so 2 events, this happening and well as well as and this happening. is multiply. Okay? So P of A or B, if they're mutually exclusive, then it's P of A plus P of B. And if we have P of A and B happening at the same time, then that's the multiplication. Okay, so just so you might want to just see that out in the same spot there. Okay, now you may be given probabilities, okay, but you may also have to, figure them out. So what I'm going to do is I'm going to do an example with you using a tree diagram, which is actually, going to help quite a bit for you. So, all right. So example 1 here in the textbook says Mokhtar and Chantel are playing a die and coin game. Each turn consists of rolling a regular die, so 6-sided die, and tossing a regular coin, heads and tails, 2 options there. Points are awarded for rolling a 6 on the die and or tossing heads with the coin. So 6 and heads. 1 point for either outcome. So if you get one of them, that's or, you get a point. 3 points for both outcomes, so that would be a 6 and a head, and 0 points for neither. Okay, so I don't know if that makes sense to you, but you roll the die, and let's say you get a 5, so you don't get a point there because it's not 6, but you toss and you get a head, so you get 1 point. Okay, if you roll and you get a 6, you know you got 1 point, but if you get a head after that too, then instead of getting 2, you get 3. Okay. So players alternate turns. Sounds like a real fun game. I should do this with my kids. I'm not sure. The first player who gets 10 points wins. Okay, so we played at 10. Determine the probability that Mokhtar will get 1, 3, or 0 points on his first turn. Okay, so this is the type of example that we're going to do. What's the probability for each point value on the first turn? Okay, so let's just think about this. Rolling a 6. Okay. Rolling a 6 is equal to 1 out of 6 for a probability, right? Tossing a head is 1 out of 2, right? So let's see. We should probably consider, not a 6 over here as well is 5 out of 6, and not a head is 1 out of 2. Everyone see that? So we have all of our sort of individual probabilities here. And now we're going to take a look at, so you get 2, you get a roll and a flip. So the tree diagram, and again, if you want to look on page 355 as we do this, the tree diagram, what it is it kind of splits things up into columns. So rolling, okay, the die here is sort of the first column, tossing the coin, and you don't have to label these if you don't want to when you're doing your work, but the probabilities here would be the final column. So this is how you set up the tree diagram. Rolling the die, what we have is and they usually kind of just start from a single point here. And however many options there are, you draw kind of a line from this single point in this column area. So rolling a die, we have rolling a 6 and rolling not a 6. Okay, I'm going to say 6 prime or anything but a 6. So what are the probabilities? And what they do is they put those probabilities kind of right here somewhere along this line. So that's 1 out of 6, and this is 5 out of 6. Okay, and this tree diagram is very visual. You'll be able to do very complicated questions with many events happening. And like I say, when we get to 5.5 after this, when we talk about dependent events, this is going to be very, very helpful for you. Okay, so we'll get used to kind of doing a tree diagram here. It's pretty important. Okay. Okay, so for tossing the coin, the second event, we move on from there, and of course these are going to be connected, right? So when you toss a coin, and I like to do this to connect them, they don't in the book, but when you toss a coin, you either have a chance of getting a head or a tail, right? And so the probabilities associated with those, of course, are 1 over 2 and 1 over 2. And down here, same thing, tossing a head with a non-6 and tossing a tail with a non-6 is going to be, these are the probabilities here as well. All right, so now in this column over here, the probabilities are going to be basically the multiplication of the individual probabilities that that show up here. So really, how many probable outcomes do we see here? In this game, we see 4 probable outcomes, right? So you could have a 6. This is going to be the probability of a 6 and a head. This is going to be the probability of a 6 and a tail. This is going to be the probability of not a 6 and a head, and the probability of not a 6 and a tail. Everyone understand that? Everyone kind of see that? And of course, what we ultimately want is to find out what these probabilities are. So for this one, and these are going to be pretty simple, pretty straightforward, we multiply the numbers that sort of follow this path. You see that? There's one stretch of the path, there's another stretch, so to get to that, we multiply 1/6 and 1/2 to give us 1/12. Right? And so we do the same thing. So over here we have a 6 and a tail. That gives us this one. So 1/6 and 1/2 too, that's also 1/12. And down here, a 6 along with the head gives us 5/6 times 1/2. So 5/6 times 1/2 is going to be 5/12. And the same over here, 5/12. Okay? So to answer the question, here, determine the probability that Mokhtar will get each one of these on his next turn. So the 3 points is for a 6 and a head, right? That's the 3. So where's the probability that you get a 6 and a head? That's up here. And so for 3 points, right, it's a 1 out of 12 probability. Make sense? For 1 point, okay, so where would he get 1 point? If he got a 6 and not a head, so that's this one, right? So the 1 point here, 1 out of 12 for this situation, but is there another situation where you could get 1 point? On our 4 possible outcomes there. Well, let's go back to the question. It says rolling a 6 or rolling a head will give him 1 point for if he just has one of those outcomes. So here's just a 6 and not a head, and here's a head and not a 6. So guess what? There should be a point here as well. Does that make sense? Oh, 5 out of 12, sorry. 5 out of 12 here. Thank you. So we're going to have to add these together, aren't we? We're going to have to add those together to get the probability for this right here. Because those are now OR, right? So if they're OR, this one or this one, the two possible, we add them together. So that's going to be 6 out of 12 or 1/2, right? So that's going to be 1/2 for 1 point. And for no points, so not a 6 and not a head, right? X that out, X that out. So there's 5, 0 points. You have 5 out of 12. Okay? Does that make sense so far? All right? So I guess the big thing here is we're multiplying probabilities, right, to get these for each part of the turn here. Over here, though, you could get a point for this one or for this one, so you have to add. That's when we add those two together. That's 1/12 plus 5/12 is 6/12, which is 1/2. Now the other thing to double check what you could do to make sure that you've done this right is that every turn they're going to get either the 0, the 1, or the 3. On every turn, you get one of those 3 options. So 1 out of 12 plus this 1/2 is 6 out of 12 plus this one is 5 out of 12. If you add those all together, all right, that should be what? It's going to be 12 out of 12. So that means that there's nothing missing. So every turn, there's a 100% chance, 12 out of 12, that you'll get one of those points. Okay. All right. So we can quickly see here, too, that there's a pretty big chance that we're going to get no points on each turn. There's about a 50-50 chance that we'll get 1 point, and there's only 1 out of a 12 chance that we'll get 3 points. Any questions? Okay, so that's it. That's example 1 in your textbook, and I'll get you to look at the summary, and then I'm going to give you your assignment for 5.6 here today.